Question 4 asked for an enlargement to be done scale factor of 3 and centre 2, 1. The scale factor of 3 means everything is 3 times as long, and the centre 2, 1 means that's where you start from. So we start at 2, 1, that's usually marked on the grid 2, 1. And with a scale factor of 3, it means all the 3 corners of this triangle are going to move to be 3 times further away from the centre. So starting at the centre, I think counting squares is probably best. This corner here from the centre is 3 along and 2 up. So if we multiply that by 3, because of the scale factor 3, we go 9 along, and not 2 up but 6 up. So that's our first point in our enlargement. Then this point here is, instead of being 1, 2, 3, 6 along and 2 up, it's 3 times as far, so it's going to be 18 along and 6 up. So that's that point there. And then this last one here, instead of being 3 along and 4 up, it's going to be a 9 along, and 4 times 3 is 12 up. So there are 3 points, and we just join them up with a ruler. Now obviously this is an enlargement, so not only has our triangle moved 3 times further away from the centre, but it will also be 3 times bigger. Question 8 was a percentage increase stroke decrease question. Now there's always 2 ways to look at this. First is a normal increase, where you have an original price, you apply an increase or decrease, and then you get your final price. And the other question could be a reverse percentage question, is where you have an unknown price, you have an increase, and you're actually told the final price. This question does both of those. If we read through it, first of all, it says the prices are reduced by 15%. Now a reduction means it's going to come down to less than 100%. In fact, it's going to be 85% because it's reduced. So 85%, we always work with decimals, don't work with percentages. So that 85% as a decimal is 0.85. Now bear in mind, if this said it had been increased by 15%, that would have taken it up to 115%. Right, and the multiplier used wouldn't be 0.85, it would be greater than 1, it would be 1.15. So reduction, you're going to get a number less than 1, and an increase, you're going to get a number 1 point something. Now the question says the normal price of a printer is 240, so the calculation is 240. And we just have to work out, do we multiply or divide by this 0.85? Work out the sale price. So the normal price started at 240, that's the starting price. The sale price is afterwards, so that's just a straightforward multiplication. Times 0.85, and that comes to £204. Now you can go and just double check if that seems about right. The normal price was 240, but it's been reduced, so your answer should be a little bit smaller. Now that is different to this question here. It says in the same sale, so we're still talking about this 0.85 as your multiplier, because it's been reduced by 15%, so it's still 0.85. In the same sale, the price of a laptop computer is 663. That's what it is in the sale. That's after the reduction has happened. So it wants to know the normal price. So again, that's the price we're given in the question, so that's what we start with, 663. But because this is a reverse percentage, where we're actually trying to find out the starting price, now this is a reduced price, so our starting price is going to be bigger. We're going to divide. Instead of multiplying by 0.85, this is going to be a divide by 0.85. And that actually comes to £780 as the normal price before the sale. just to re-emphasize, whenever you get a percentage increase or decrease question, always find the multiplier. I know a lot of people decide to work out 15% of 240 and then they go and take that away from the original price. That method will work for normal percentage increase decrease question, but not for the reverse one. When you get a percentage increase or decrease question, always use the multiplier method. Question 9 is an inequality. You solve these in exactly the same way as you solve an equation, except for you keep the less than or greater than sign there instead of the equal sign. So we've started off with 2x minus 3 is less than 5, so we isolate the x term, so we add 3 to both sides, and that gives us 2x is less than 5 take away 3. That's going to be, sorry, it's 5 plus 3. I'm adding 3 to both sides, so that's going to be 8. And then I can divide by 2 to get x on its own, and that leaves us x is less than 4. So that's our answer to the first part. And this second part, it goes and says n is a positive integer. Write down all the values of n which satisfies the inequality 2n minus 3 is less than 5. Now this is exactly the same as the expression up here, which the expression up there we've simplified to x is less than 4. So the expression here will simplify to n is less than 4. In all the questions I've seen, it's always been the same expression. It's just this is a general one with an x and this is a specific one with an n. So we use that n is less than 4 and n is a positive integer. So n is a positive integer less than 4. What can it be? It's got to be 1, 2 or 3. Question 10 is a frequency table. It's a frequency table because this column here is frequency. It tells you how many times the values in the first column actually occur. Not only is it a frequency table, it's a grouped frequency table because these aren't single discrete values here. This gives you a range of values. So it's saying that between 10 and 20 there were 8, a frequency of 8. Between 20 and 30 there was a frequency of 38. Now you actually ask for an estimate of the mean, and the reason it's an estimate is because you cannot calculate the exact value, because these 8 results, you don't know the exact value. All you know is those 8 results were somewhere between 10 and 20. You don't know what the exact value is. They could have all actually been 20, or they could have all been sort of 11 or something, but you don't know. You assume that you had some high and low, but you assume that they average out to be the middle value. And that's the first thing in these. When you have a grouped frequency table, you need to have a column, because you don't know whether you use 10 or 12, 20, so you use a number in the middle. So you actually need a midpoint column, and there should be enough space in the question for you to actually go and add that as a separate column. So the midpoint between 10 and 20, that was going to be 15, and between 20 and 30 is 25. That's 35, 45 and 55. It should be quite easy to work them out. If you can't work them out, the trick would be you add the two numbers together and divide by 2. That will always find you the number halfway between them. So 30 and 40 makes 70, divide by 2 makes 35. We now don't need these values, because the values we actually need are the midpoint values. And we now need to go and find the estimate for the mean. The estimate of the mean is going to be, it's the age, so the mean age is going to be the total of all the ages divided by the number of ages, which is the number of members. Each of them have one age. Number of ages that exist, well, members. So the total of all the ages, well, these 8 count as having an age of 15. So to get the total of those 8 people, you effectively extend this column here. 8 times 15, which is 120. And these 38 people, we're assuming their age average to be 25. So we're assuming their ages were all 25. So we do 38 times 25, that's 950. In a similar way, these 28 people, at an age of 35 is 980, and these 4 age of 45 gives us total age for that lot 180, and these 2 people at age of 55, that's a total age of 110. Now if you want the total of all those 80 members, we add up those rows and we get 2,340. Now you would get marks for using the midpoint, would be 1 mark. Actually multiplying to get the total ages is usually a mark. You possibly get a mark for showing this row, definitely get a mark for showing this figure here. So then when we calculate the mean, we're going to use the total of all ages. The total of all ages came to 2,340, and divide it by the number of ages. Well, there were 80, the question says there were 80 members, and if you actually add up all the frequencies it comes to 80, so you divide that by 80. And 2,340 divided by 80 comes to 29.25. Now that is a process you just need to learn and apply. It frequently comes up. It doesn't get any more difficult than that. It's just different numbers. Part B of this question is cumulative frequency. Now this will always be derived from an earlier table. So this is a cumulative frequency. We more or less sort of go and have a look at these upper bounds. We sort of said, okay, we start at 10, but how many up until 20? How many less than 20? And if we look at the original table, there was 8 of them up until 20, so the cumulative frequency there is just 8. Next one says, okay, up until 30, yeah, between 10 and 30. 10 was a starting point, so how many values up until 30? Well, we look in the table, there's another 38 values in that second row, so another 38 plus the 8 in this row are going to give us 46. And what about up until 40? Well, in this third row, which is up till 40, between 30 and 40, there's another 28 people. So those 28 get added to the 2 previous rows, and we go and get 74. And likewise, there's another 4 people in that table above. Yeah, another 4 and another 2. So if we add those on, add 4 here to get 78, and add 2 more, 80. These are cumulative frequencies. The next part of the question C says, on the grid, draw a cumulative frequency graph. Now the cumulative frequency graph is going to be those points from that previous table plotted. The lower boundary is always the same, so you can ignore. So you're going to plot 20 against a cumulative frequency of 8, 30 against a frequency of 46, 40 against a frequency of 4.7. So that 20 with 8, so that's going to be 20 with 8, so just make sure the scale, that's going to be 10, 8 is going to go there. Okay, and I'll just put the other points in. So here are all the points from that cumulative frequency table. Now I don't know what people were doing. Some people, they were drawing bar charts or histograms or something. A cumulative frequency is a curve. That's just something to look. A cumulative frequency graph, it's a curve. You plot your point and you join it with a curve. So I'm going to join my curve here. That top bit is easy to see. Yeah, the curve's going to come somewhere around there. So I'm just going to start my curve there and then curve it round. I'm trying to do it nice and smooth. And then this bottom bit, it turns round. So turn your paper round. I'm actually going to join it to the 10, 0 because there was no one up until there. So that is technically another point on this particular graph. And then I'm going to sort of get inside and try and draw it there. It's going to be quite a sharp turn there. So maybe I start with that sharp turn to make sure I get the turn right. And then take it that way. And then bring it up there. And that's my cumulative frequency curve. Okay, it's a curve, S-shaped curve. Then it says use your graph to find an estimate for the median. The median is a middle value. What's the total number of values? We'll look at the graph and you think, well, the total number of values up here is 80. So the median is going to be 80 over 2, the halfway point. With cumulative frequency, we don't do 80 plus 1 divided, but we can just do 80 divided by 2. It's not going to make a lot of difference on the graph. So 80 over 2 equals the 40th value. And the 40th value we just Find our graph. Well, here's our values. There's the 40th value. So that's the value we want. And we get our ruler. I'll follow it along with my pencil. That's where the graph crosses that 40 line. So I'll draw a line there. The examiners want to see that line. And I take it there. I'll follow it down from there. It's going to come down there. So that is my line for that. Since this is an exam, I'm going to put a little arrow there and write 29 because that's the reading and that's my working out for the examiner. And the answer there, 29. Question 11 was a quick question on rearranging formulas. It says make W the subject of the formula, so I want to end up with W equals something. However, if I look here, W is under a square root, so I've got to undo the square root. How do I undo a square root? What's the opposite? It's squaring, so I've got to square this right hand side and square the left hand side. So I square the left hand side, I get h squared, and I square this right hand side, it undoes the square root, doesn't it? So I'm just left with W over I. It's actually W that I want to isolate, the formula in terms of W. So using this, h squared equals W over I. I've got W except for it's been divided by I. So how do I undo a divide by I? I do the opposite, it's times I. So multiply both sides by I. This becomes h squared times I, and this becomes just W because the i's will cancel. So W equals h squared times I. Question 19 was about probability, about counters in a bag. The key thing here is he takes a counter at random from the bag, he records the letter which is on the counter and replaces the counter. It replaces the counter. You must get that in your head and always think, okay, you're going to do something once, and then when you do it a second time, it's exactly the same probabilities, which means you've got 6 counters here, and it's always going to be 6 counters. And there's 1 B, so the probability of a B is always going to be 1 over 6. 3 A's, the probability of an A is always going to be 3 over, I can write that here, probability of a B is always 1 over 6. The probability of an A is always going to be 3 over 6. And the probability of an N is always going to be 2 over 6. I'm not going to bother simplifying these at the moment because I'm going to use them in calculations. I will keep them as 6ths. It just makes everything much easier. The question actually asks not what the probability of individual counters are. That was an earlier question. This is about combined probability, where you have 2 things happening one after the other. And it says calculate probably first letter will be an A and the second letter will be an N. Now please, can you get in the habit of actually writing down what the options are? It's write down probability of an A followed by an N. I would just put A, you could just put AN. I put a comma there just to separate. Probability of an A followed by an N. And the probability of an A was 3/6, and of an N was 2/6. So you just multiply them together to get the overall probability of one thing followed by another. One thing followed by another is multiplying. So that gives us 6 over 36, which I keep it there like that, but that's simplified because I need the final answer simplified. That's just 1/6. The second question is a bit more involved because it says calculate the probability both letters will be the same. So I'm picking a letter, putting it back, picking another letter. Well, there's 3 letters here to start with, so I could either get a B followed by a B, an A and an A, an N and an N. So I need those 3 options down. So I write them here. I prefer to write them down vertically. I can get a B followed by a B. I can get a probability of an A followed by an A, and the probability of a N followed by an N. Now that's the only way to get 2 letters the same, those 3 outcomes. And then I just work out the probability of each of them and add them together at the end. So BB, that's going to be 1/6 for the first B and 1/6 for the second B. Remember, it's it is replacement, so the probabilities stay the same. That comes to 1 over 36. of AA, well, there's 3 A's, so probably of 3 over 6 times 3 over 6 for the second A, and that gives us 9 over 36. And for an NN, there are 2 N's, so there probably is 2 over 6 times 2 over 6 for the second N, and that comes to 4 over 36. Can you see why I've kept them in 36s now? Because it makes it easier to add. If I simplified them now, I would have to just put them over a common denominator before I added them. But now I can just go and say 1 and 9, that's 14 over 36. The total there, those three, the total is 14 over 36. And then this is an answer which I'm going to write down, so I will simplify it, and that becomes 7 over 18. Question 21 was similar shapes. The first thing you must do with all similar shape questions is find the scale factor. In this particular one, you are told 2 matching measurements, but it is for the surface area. The surface area of the first one is 157, and the surface area of the second one is 2,512. You want the scale factor. This compares areas, and so what you do is you divide the bigger by the smaller. Yeah. 2512. I always do bigger by smaller because you just get nicer numbers. But because you're comparing areas, the scale factor is not 1 divided by the other, it's the square root. Okay, because it's area. If it was volume, if you were told 2 comparable volumes, you'd do 1 divided by that, but find the cube root. So the scale factor is going to be the square root of that, and that actually comes to 4. The scale factor is 4, and that's what we're going to use in the rest of the question. So part A, once we've found the scale factor, the rest of it's quite easy. The length of the cuboid is 26, so we're talking a length here, and this is cuboid T, that's clearly the bigger one. So I take the length I've given, which in the question it's just 26. Am I going to multiply or divide by the scale factor? T is the longer of the length, so I need to divide by the scale factor to get the shorter one. So it's 26 over 4, and that comes to 6.5. On part B, it says the volume of S is 130. Calculate volume of T. So I'm going to start with 130 because that's what I'm given in the question. And volume of T. Now S is the smaller shape, so I'm going to multiply to get to the larger. So it's going to be times 4, except for it's not times 4, because that is the scale factor tells you how much the lengths are multiplied by. Volume is 3 lengths multiplied together. A length times length times length. We've got to use a scale factor cubed to get a volume. If we wanted to find the square, we'd have to use scale factor squared. This is scale factor cubed because we're trying to find a volume. So 130 times 4 cubed, that actually comes to 8,320. The maths behind this is not complicated. It should be a question that you rejoice for getting in the exam because it's pretty run-of-the-mill, and they've never actually put any funny wording in it. They just give you different initial comparisons here. Sometimes they'll tell you 2 lengths which match, then you just find the scale factor. Sometimes they give you here the 2 areas which match, sometimes they give you 2 volumes which match, and then you've just got to use the scale factor if you want to find a missing length, or you use a scale factor squared if you want to find a missing area, or you use a scale factor cubed if you want to find a missing volume. Simples, yeah?